Everyone, welcome to Shorus's classes. We are back with another problem solving session, ISI Msqs. It's the subjective portion. So the ISI Msqs is one of the most celebrated courses that is offered by the Indian Statistical Institute. This is for those who are unaware of this. So these set of videos are primarily designed for persons who are aiming for or aspirants of ISI Msqs this year or perhaps some years. So this problem series or the problem solving session series videos will be aimed in solving subjective problems from the past year question papers, so that we all may know that what type of questions we are going to face in the examinations. We need to familiarize with that in the previous year. So for that I have chosen the 2019 question paper, the question of 2 part A, that is, prove that if x is greater than 0, y is greater than 0 and x plus y is equal to 1, then 1 plus 1 by x times 1 plus 1 by y. So here the y is missing, I guess. So 1 plus 1 by y greater than equals to 9. So I request everyone that to pause this video and try this on your own, because as I keep telling that everyone that trying a problem on the own is one of the biggest gifts that a person can get. So for everything you must try a problem on your own. That is very essential. Even you might not be able to solve that problem, but trying is very important. Without trying you won't be able to get the crux. So if you have already tried and solved, then it's well and fine, and if you did not, you need not be worried, because trying is very essential, as I have told. So the problem, this problem in according to the comments part as I give for every problem. So this problem does not require any fancy theorems. It will just require the simple arithmetic mean, geometric mean inequality. So let's see how. So we know that by AMGM inequality, what we get is okay, so this is what we get. So we know that arithmetic mean of two numbers is greater than the geometric mean. Now what is x plus y given? X plus y is given as 1. So 1 by 2 greater than equals to root over of x plus y, xy. So I mark this equation 1, and from here what I get is that xy is, I get is 1 by xy is greater than equals to 1 by 4. So I mark these two equations, equations 1 and equation 4, that we will be using very frequently. So now we will just head on to the next part of the solution. So for the next part of the solution, I just shift the camera a bit down. So the expression that was given to us is 1 plus 1 by x. So this was the expression that was given to us in the question. Now what we do is just simple multiplication, 1 plus. So this is the multiplication form, and I take LCM and just add it up. So let's see. The value of x plus y is given as 1, so I substitute 1 here, and what I get is that 1 plus 2 by xy. Now here comes the usage of equation 2. So sorry, it's not 1 by 4, it will be 4, as I have taken reciprocals on both sides. So I just made a change here. So that's not 1 by 4, that was a very unintentional mistake from my part. That will be 4, since I have taken reciprocals on both sides. So here what it will be, so this is greater than equals to 1 plus 2 into 4. As you have seen that 1 plus 2 into 4, so from the above inequality, equation number 2 that we did, we get it to be 4, and we just substitute that value here, and this is nothing but 4 into 2, 8 plus 1, 9. Okay, so what I get is 1 plus x into 1 plus y is greater than equals to 9. So this was just a simple problem. Now I want to draw your attention on a conceptual part of the problem that we are solving. So I'll just get back to the camera in the same position. So now we have proved from this method that and we have applied AMGM inequality here. So we didn't mind checking many facts on the AMGM. The first fact that the AMGM inequality requires is x and y are positive. Now obviously you will tell that of course it is positive. This is because that was given in the question, x greater than 0, y greater than 0. Exactly correct. So I must say that you are absolutely right that they are positive, that is given. But the most important part of AMGM is the equality condition. It says that equality holds when the variables x and y are equal. So equality holds when x equals to y. So that is what it says, isn't it? So the fact is that we have openly applied AMGM without checking that whether after each step that I apply, the equality part is conserved or not. Okay, so we cannot be sure that this equality part holds true or not. So it will not be appropriate to write this. So at first I will only write this greater than equal to. Now how will I verify that it is equal to? I will put x equal to y equals to 1 by 2 and check that it is indeed 9. So there is a value of x and y for which it is indeed 9, and since that is now very clear to us, we will get a greater than equal to. Okay, so mind it, my friends, those who are watching the video, that the equality part for any inequality is very important. This is because you might apply the inequality, you might proceed step after step, step by step, step by step. But at certain step, the equality part might be changed. So you need to take a very serious step or very serious look at that part. That is my advice. This is because then you could, because if that is not taken care of, then we can be in a great trouble. Means we can just prove out fallacious results from the question. So now I will get down to the next question. So this is the second problem, the part B of question number 2. So it says that the given integral, that is integration 0 to 3 dx into x minus 2 whole to the power 1 by 3 has a finite value, and we are asked that we need to find the value. So I again request everyone to solve this problem by yourselves before checking the before checking the solutions. So now we will just do it. So we know that these types of integrals are very popularly done by the method of substitution. So the substitution method works here. So as in every general cases of integrals that we have seen, the substitution method will also work here, and that will make the problem much easier. So let's see how to solve that. Now x minus 2 equals to t. So we take x minus 2 times equals to t. We take 1/3 power. So t1 by 3, and from here I can easily say that dx equals to dt. And we see that the problem is merely solved. So I write I as the problem. So I equals, now when x is 0, so t is minus 2, so we need to change the limits. And when x is 3, t is 1, so the limit becomes minus 2 to 1 dt by t power 1 by 3, isn't it? So integration minus 2 to 1 t power minus 1 by 3 dt, which is nothing but t power minus 1 by 3 plus 1 by minus 1 by 3 plus 1, 1 by 3 plus 1, minus 2 to 1. There is no constant of integration because this is definite integration going on. So t power 2 by 3 now we will just subtract it, and let me just shift the camera a bit downwards. So for subtracting this I get that the top minus the bottom, so 3 by 2 minus 3 . Okay, so this is the answer to our problem. So this is basically the answer, and the evaluation result you can easily get. So this is all for the second problem. Now in this video we have learned quite a lot of things we have learned about AMGM, though the questions that were discussed are not of a very fancy type, though these are direct questions that are taken from the ISI question paper. So the questions that are discussed are not of a very fancy type, so they require simple inequalities like AMGM. But as I have said, that please keep in mind about the equality condition of the equalities. So these must be practiced. So as you know that only practice, I keep telling everyone that only seeing these videos won't serve as a solution to the problem of the entrance, so you need to practice it on your own. So go ahead, practice more. For serious aspirants of ISI MSQE, Saurav says classes in Kolkata publishes great quality study materials with concepts, tips and tricks and other techniques that I discuss in this video, with solved questions and also a lot of questions for practice. So I recommend everyone to solve these questions and get a copy of your own very soon, and try solving the exercise problems and tally with the solutions, so that you feel more confident, more better, and crack the ISI MSQE exam with flying colors. So that's all for this video. Best of luck. We will meet to the next video, and best of luck for your exams. Thank you.